All right, today we're going to continue our work with solving equations, and we're going to extend it to solving multi-step equations. And this video will have an introduction and a couple examples that I will solve with you. So a couple things to consider up at the top here, and these aren't necessarily mandatory rules. You might choose to do some of these, you might need to do some of them. It really depends on the situation you're working with. So these are just things to consider. Combining like terms if you can. It's nice to be able to simplify what you're working with before you start solving. Simplify fractions. Often that involves either multiplying both sides by the denominator or getting a common denominator so you can add or subtract fractions. Keep in mind there are often multiple correct paths to follow. Some will be more efficient than others, but if you follow them correctly, they will all get you to the right solution. A trick to get rid of decimals is to multiply everything through by a power of 10. I'll show an example with that. It'll just be easier to work with larger integers than with smaller decimals. And as always in math, we want to show our work and check our solution. So let's get started. This first one right here, first couple that you're seeing here, looks like we need to solve for x. What I'm not going to model here is building the onion. I did that in an earlier video. Hopefully you're feeling pretty proficient with that right now, but I'm not going to actually model doing that. For this first one, it looks like we can combine some like terms first. So I have an 8x minus 2 equals 22. And then we can do some work with that. I can add 2 to both sides. And that will eliminate the subtraction of 2. We have a 24 on the right, and we have an 8x is equal to 24 on the left. It looks like we can divide both sides by 8. We're almost there. These 8's cancel. We have an x is equal to 3. For some of these harder ones, it's worth it to maybe sometimes go through a more formal written check. Certainly at least do a mental, thoughtful check in your head. But let's do a more formal check right here. We have a 3 times 3 minus 2 plus 5 times 3. And we're wondering if that's equal to 22. Is 9 minus 2 plus 15, is that equal to 22? 7 plus 15 is 22, so that checks out. So it looks like we did that one correctly. Next one, again, it looks like we want to combine some like terms. Here's a common mistake people sometimes make. They think that subtraction goes with the 5. It actually is talking about what we're doing with the 4x. So in this case, I'm going to do x minus 4x to get a negative 3x. Plus 5 equals 4. Subtracting 5 from both sides, it looks like we have these 5's cancel. A negative 3x equals 4. Take away 5 is a negative 1. We can divide by negative 3. And our negative 3's over here cancel. That was the whole point of dividing by negative 3. These negatives cancel, and we have x is equal to 1/3. And let's think about doing a quick mental check. Is 1/3 plus 5, so that's 5 1/3, minus 4/3, is that equal to 4? It is equal to 4, so we did it correctly. Next one we'll look at, I really want to show you how there are a couple pathways to follow. And first we will apply the distributive property, and then I will show you that we didn't need to apply the distributive property. We'll go through a second pathway. So let's distribute here. Negative 3x plus 6 plus 5 is 53. So negative 3x plus 11 is 53. We have it simplified as much as we can. Let's subtract 11 from both sides. Oops. And we have these guys cancel. Negative 3x equals 53 minus 11 is 42. We can divide both sides by my negative 3. and we've isolated for x. 42 divided by negative 3 is a negative 14. So I'm not going to check that. I'm going to actually solve it a different way and call that my check. Let's see if I get the same answer solving it a different way. So let's rewrite the problem again. We have a negative 3 times the quantity x minus 2 plus 5 is equal to 53. So I'm actually going to subtract the 5 first. And these 5's cancel. We have negative 3 times the quantity x minus 2 equals 48. And what I'm going to actually do right here is divide through by negative 3. So I'm not going to do the distributive property. I'm going to divide through by negative 3. But keep in mind, if you're following this method, we needed to have subtracted the 5 first. If we were to divide by negative 3 first, that 5 would turn into a negative 5/3. It would still be mathematically legit, but it would be somewhat tricky. So let's continue with this process. We have an x minus 2 equals negative 16, I think. And then adding 2 to both sides gets us x is equal to negative 14. So that makes me pretty confident that I did it correctly. I got 2 equal answers. And I think you can do a little bit of thinking about which one might have been the easier or preferred pathway for you. Next one here is dealing with some fractions. And there are a couple different pathways here that you could follow. I'm going to take the one that seems easiest for me, and for some reason I want to avoid getting a common denominator here. It seems easier to me to multiply through and get some larger numbers. So let's follow that process here. So I'm going to multiply everything through by 15, and that is the least common multiple of the 3 and the 5. And you'll see what happens here. And you don't really even need to do the least common multiple. It could be any common multiple, and things will cancel pretty nicely. Okay, so let's distribute the 15 all the way through. We have a 30 x over 3. Just remember that when we multiply the 15 times the 2x over 3, that's 15 over 1, and we're multiplying the numerators by each other and the denominators as well by each other. So we don't want to multiply the 15 by the 3. Plus 15x over 5 equals 52 times 15, 780. And you might be thinking, why the heck did we do that? We still have fractions that we need to deal with. Well, these can be simplified. 30 divided by 3 is 10, so we have 10x. 15 over 5 is 3, and that's all equal to 780. So we have 13x equals 780, and we really only have one solution step that we need to follow. We will divide both sides by 13. And I get 60. X is equal to, after these 13's cancel, x is equal to 60. This is a good one to go through. I think I can do a mental check. The numbers are pretty straightforward here. So 2/3 of 60 is a 40, plus a 1/5 of 60, so x over 5. I'm up here, by the way, to doing my check. 2/3 of 60 gives me a 40, plus x over 5. 60 over 5 is 12. Yeah, that does equal a 52, so it checks out. And then lastly, for this video, we will work with decimals. And this was another trick I wanted to show you. I want to multiply both sides by 100. And let's see what happens with that. So we can distribute the 100 through on the left side. And what this is going to do is it's going to get rid of our decimals. And it just makes things a little bit cleaner, although we will be working with larger numbers, and I think that's an okay trade to make. 64, subtract 64 from both sides. These guys cancel. We have 403x equals 4,900. That's 4836. And let's divide through by 403. And what do we get for that? We get a 12, so x is equal to 12. This is a good one to do a formal written check, I believe. Let's do a 4.03 times 12 plus 0.64. We're wondering if that's equal to 49. So I'm just going to run that through on my calculator. 4.03 times 12 plus 0.64. And it does, it checks out, it equals 49. Okay, so it looks like we got the correct answer. That's a great place to stop, right there.